Let's start this up. All right, first thing, here's where we're going today. Will came in earlier. He shows me two triangles. He goes, look, I just did a rotation of a triangle. He goes, do you know why my two triangles are congruent to each other? Anybody help Will out? He did a rotation of one triangle. He's got two on his diagram. He's got two on a graph right now. Anybody explain why the two triangles are congruent? Nick? What do you know about a rotation? Correct, right? The size and shape doesn't change of the triangle. What else does that other than a rotation? Translation and a reflection. Okay, so that's what we're going to be doing today is, hey, what did I do and why are the two triangles still congruent? And there's some exact wording that the Regents looks for. Pretty important day here. I would say probably the most important day of the unit here. All right, so I'm going to tell you what's happening, and you got to tell me why the two triangles congruent. You'll see a lot of fill in the blanks here, because I think this is the best way to show you what exactly needs to be said to prove the two triangles congruent. So let's basic one here on number one. What did I do here? After a reflection over a line, triangle ABC is the image, triangle A prime, B prime, C prime, image of ABC. Can you explain to me why triangle ABC is congruent? I'm going to give you a little template today on how to explain why they're congruent. All right? So do you think you can help me fill in the blanks? Reflections are rigid motions, yes. So first thing you guys need to tell me is, what are you doing? And tell me they're rigid motions. All right, reflections are rigid motions that preserve, we'll get there in a second, that preserve, well, they don't preserve sides, they preserve the distance of them. So they preserve distance and angle measure, yes. Because remember, if two figures are congruent, their sides are all congruent and their corresponding angles are all congruent. Okay, so that's just the first part of doing these, is telling me what you're doing, and then telling me that because they're rigid motions, they preserve distance and angle measures. All right, not too bad. You ready? I'm just going to keep building here. Ooh, all right, now it's a little bit trickier because you have to identify the transformation. I'm not going to come out and say it's a reflection, translation, rotation. This is the toughest part of today, is identifying how I get to one triangle from the other. Okay, so I'm going to give you guys about two and a half minutes if you want to discuss it into your group. How did I get triangle ABC on top of XYZ? And I'm looking for one transformation, not a sequence of them, one transformation that mapped ABC onto XYZ. Okay, so discuss it with your group. One and only one transformation. That's all I'm looking for here. One and only one. Did you guys identify the transformation? Any groups want to fill me in here? What do they do? What do you guys have? Okay, here's the thing now. We're in the transformation unit, and here's what the Regents is going to expect. This right here is not going to cut it. You need to be more detailed. In fact, I need a rotation with the degrees and where you rotate it around. Okay, so all right, yes, so I need to see this is a rotation of 180 degrees, and I apologize, I didn't give you enough blank space here. Rotation of 80 around the origin. So if you ever say it's a rotation, you need to add on the degrees and where you're rotating around. If you add on a reflection, guess what else I need with a reflection? The line you reflected over. If you say a translation, what else am I going to need with that translation? Up, down, left, and right you moved. All right? So we know it's a rotation of 180 degrees around the origin. Since rotations are, okay, you guys are starting to get the template now that we are looking for. Rotations are rigid motions. They preserve distance and angle measure. And we added a new one in here now. You like that? Thus. What? Thus congruent. Thus triangle. Therefore, if you'd like. Anybody else? Thus, there.
All the words are British words, Will.
Therefore, thus. Anybody have another one? And so, in conclusion. Alas, that's a alas. Okay. Okay, little bit, now another level above. This last one that we had, why am I feeling I'm going to regret this? Last one that we had, it was one transformation that moved the triangle onto its image. Now it's a sequence. I knew I was going to regret it. I knew it. Why do I keep doing this to myself? I knew I was going to regret that. All right, let's go. Come on, let's go.
It's not. Okay, I'm not gonna say that because maybe it is. What about that cube turn?
We just saw that. We just saw that.
I know, but before that I said.
Or in.
Wait, is clock the one that goes this way?
Yeah.
Or is that wipe? We get clock one.
No, wipe is just
Oh no, what about the one where it like curls up?
page curl. Page curl.
I like the page curl.
There's a difference between curl is when it comes up from the corner. Turn is when it like cuts itself in half and flips it off. What do we got here? Come on.
Page curl. Page curl.
I got curl. I got clock. And now I have star. Got to throw the star in.
We just said that.
Okay, so I feel like the chances of you being right times in a row are slim.
But still.
We have to go for star. We have to just go.
Stars now making a comeback.
Clock or curl?
Okay, here you go. Here are your options so we can move on. You got star, you got clock, and you got curl. Stars. Who's the stars? Anybody want star? 1, 2, 3, 4, 5, 6. Who's got a curl? 1, 2, 3, 4, 5, 6. Perfect. Who's got the clock? 1, 2, 3, 4, 5. Hold on. 1, 2, 3, 4, 5, 6. Really? Really? Really?
Yo! Did you vote?
Really?
Justin decided to vote. Go.
What do you got? You got star, clock, and curl. Okay, clock. Here we go. Clock it is. Everyone ready? Ready? Clock. Or Promethean man. Here we go. Clock or Promethean man. Ooh, curtains, curtains, curtains. All right. Okay, good times. Let's go backwards now. Okay, here you go. All right. Sorry, it happens. Okay, this one's a little bit more difficult because now it's just not one transformation, it's a sequence of transformations, which means 2 of them now. So within your group, within the next 2 minutes, can you figure out how ABC gets to A prime, B prime, C prime in 2 moves? Okay, 2 moves, be specific. If you're going to say a reflection over what? If you're going to say a rotation of how many degrees? Okay, so 2 transformations right now. How do I get ABC to A prime, B prime, C prime in 2 moves?
This is more important.
Anybody find, you think you found the sequence? And there could be different ones here. All right, there could be different ones. I'll listen to just one of them here. So ABC undergoes a, what's your first transformation? It happens. A reflection, okay? Where's the reflection? Okay, a reflection through the y-axis. And I know it's easy because I had the blanks there, but you're not going to have blanks on the Regents exam here, and I'll have one coming up next that has no blanks. And so I reflect ABC through the y-axis. Now, how do I get that one down to A prime, B prime, C prime? So reflection through the y-axis and a translation. Okay, be specific. Where are you moving it? A translation of 0, -3. Again, we could write that a couple ways. You could leave it in vector notation. You could write it in the function notation I showed earlier for the homework question. Now here's a question. Could you go down 3 first and then reflect over the y-axis? Would that still get you there? Could I do that? Okay, so I'm just showing you. I know I put the blanks in this order, but you could also say a translation followed by a reflection, all right? And then finishing up, since what 2 transformations you just performed? Since reflections and translations are both rigid motions, they preserve distance and angle measure. Thus, triangle ABC is congruent to triangle A prime, B prime, C prime. Okay, so the toughest part, I think, is going to be identifying what you need to do, because the rest is all pretty much the same wording. Okay? All right, next up. Oh, a little page scroll. You guys missed that one. I said the page scroll. All right, next one. Graph triangle A prime, double prime B, double prime C, double prime. You're going to translate it 5 units to the right and 2 units up. And then after that, you're going to take that triangle, reflect it over this line. Quickly, whoa, before I let you go on your own. Y equals 0. Another fancy name for y. Whoa, think about it. You guys know this. Y equals any number is what type of line? Horizontal line, so it can't be the y-axis. It's the x-axis. So go ahead. I need you guys to plot triangle A double prime, B double prime, C double prime. And then I'll ask somebody for the coordinates. All right, little help. A double prime. What do we ended up with? 6. 6, -3. B double prime. 9, -3. And C double prime. Okay, great job, everybody. Questions? Anybody want to review how we got those points? Okay, no blanks now. Yes, Cam.
So when you reflect it, like over y equals 0, that's when the line is like this, right?
Correct. Horizontal. Or y equals any number. Plug any number and it's going to be horizontal. No blanks here. No blanks. What's a good explanation why they're congruent? What did we do? What 2 transformations did we just do? Translations and reflections are what? Are rigid motions, which preserve distance and angle measure. And then you get the pick here. What do you want? Thus. Triangle ABC congruent to triangle A double prime, B double prime. How about I write the triangle symbol in there? Does anybody have a problem if I do the first homework problem with you? You can get that out of the way. I don't know. I don't know. I just want to ask though. I guess I'd go with majority. Okay, and really you gotta, I know it's hard because it's already there, but try not to look at the blanks because I know the blanks kind of lead you to what I'm looking for here, because this was a question on a Regents exam last year, actually, last June, and not many people got full credit on it. All right, here's why: it wasn't on a graph. So people couldn't say up and over, couldn't say rotate this many degrees. All right, we had a problem here. So first thing is, let's talk as a group. How the heck would I get, what transformations, because it's a sequence here, could I do to get triangle ABC right on top of triangle DEF? I could rotate it. Is that the only way? Because it's a sequence, because rotating it won't do it. Because rotate it's just going to leave it in this spot right here. I need to get it right on top of DEF. So I would probably have to rotate it and slide it, translate it. Okay? But I need more than that, though, as you know. Okay, saying rotate and translate, and that's what kids did last year, and they got a point or 2 off for this one. All right, because they just wrote rotation and translate. They didn't get any more specific. Okay? Are you going to be able to tell me the degree measure you rotate? Probably not, and that's all right. But you still need to tell me, and this is where kids got credit off, is rotate around what? Okay, rotate around what? Okay, here's 2 options. You could rotate around any of the point vertices. Do you remember how to find the center of rotation? Oh, remember that a couple days ago, how did we find the center of rotation? You connect a pre-image and an image and do the perpendicular bisector. Then you do it again, and where those 2 intersect, that's your center of rotation. So you could, yes, you could use your compass to find the center of rotation. Okay, I don't want to get out the compass, though. So as a class, let's make a decision here. What point do we want to rotate around? Why do I always ask this? A it is, all right? Let's just go A. Okay, which direction do we want to rotate it then? Because remember, it's got to match up. A is going to have to eventually match up with D, B is going to have to match up with E, and C is going to have to match up with F. So if you guys are going to rotate it around A is going to stay where it is. So where should I rotate it? Clockwise or counterclockwise? Clockwise. All right. So rotate ABC clockwise about point. We picked A, and again, B and C would also be fine. Now here's where the catch is going to come in. Okay, we rotate it around point A clockwise. How would you tell me where I slide it? And to the right's not going to cut it. How else can we describe a translation without using numbers? We can describe it using a, it's already up there too, but a vector that shows me the distance and direction I need to slide it. So if you guys chose point A, what does A match up with in the other triangle? Point D. So what you could tell me is, all right, if you want to rotate around point A, then you have to slide it along vector AD. See that? What if you pick B? You'd do it over vector BE. And then if you picked C, you would do it over vector CF. Okay? And then translate along vector AD. So it all depended on what point you rotated around, what vector you chose. And I think you guys can finish it from here. All right, everyone all right? If you're not on a graph, you can still rotate around a point and translate using a vector now. Okay? Questions? Okay, that next one's going to be a little tough, number 2, because you got to find a sequence there that does it on the graph. That's going to be a little tougher than the one we did last problem. But I'll leave it up to you. Talk to other people about that.